Welcome to section 6.1, where we begin to look at the simplex method. Now in section 5.3, we saw situations like the following, where we had a set of constraints, an x and a y less than or equal to something, and then we had x and y greater than or equal to 0. This constraint basically said our solution was in quadrant 1. We then graphed each one of these lines and then shaded the part that was feasible. Now by doing all of that, that was back in section 5.3, we got a feasible region and we got some corner points. So that's all fine. We can maximize a function p, and the maximum has to occur at the corner points. The problem is, what if we have too many of these constraints and too many variables when we can't graph the situation anymore? So what do we do? So there must be a better option, and an option that we could eventually computerize. So let's see how to go about that process. So step 1, I have an x and a y now, but if I had more variables than 26 of them, well then, I can't keep calling things x, y, z, a, b, c. So we label the variables x1, x2, x3, x10, x100, however many that we have. Alright, so I've just rewrote, instead of x and y, an x1 and an x2. Now, I have a sum of two things and it's less than or equal to 32. So you have to ask yourself, okay, if I add these two things and it's smaller than 32, then seemingly if I added something more, I could make it equals. And so I do that for each of my constraints. So in the first constraint, I'm adding S1, and that'll bring it up to 32. And I'm adding S2 to the second one because it's probably not the same amount as the first one. And that'll bring it up to 84. This S1 and S2, they are called slack variables. They take up the amount that I need to get up to 32 and 84. And you would do that for each constraint that you have. If you had 3 constraints, you'd have an S1, S2, and S3. Once you do that, you make a table. Now, what's in this table? Well, first off, you see in the table I have listed x1, x2, S1 and S2. That's the only variables that we have. If you had more x1, x2, x3, then you'd list them there as well. And if you had more of these slack variables, you would list them there. So we only have 4. At that time, how do you fill this table out? What I need to do is pick 2 variables at a time to be zeros. So here's x1 is 0, x2 is 0. Now if we do this systematically, what do I mean? Well, x1 and then x2, x1, s1, x1, s2. That means I picked all the combinations where x1 was 0 and then everything else could be 0. Then I go to x2. x2 is 0 and then s1 is 0. Well, x2 could be 0 and x2 0. And finally, the only other possibility is S1 and S2 is 0. I have to list in this table all possibilities where two of the variables are 0. Now, there's a way to predict how many you're going to have. And that prediction is if m is the number of slack variables, then you're going to have m plus 2 columns. Okay, we have 4 columns, 2 plus 2. And the number of rows you're going to have is m plus 1, m plus 2 over 2. So in our case, there are 6 rows. Now, don't let that complication bother you. All we're doing is picking two variables at a time to be 0. There's nothing more than that. If you want a more detailed way to look at this, there is a formula. Where does this formula come from? Well, it comes from if I have n objects and I look at all the combinations picking r of them at a time. The formula is n factorial over r factorial n minus r factorial. Now later in the semester we'll get to what factorials are, what combinations are, but what's happening at this point is all I'm doing is picking two variables at a time to be 0. So take the very first set of equations. Where did they come from? Back up to here. So everything I'm going to talk about now comes back to these two equations. Alright, so step 4 is to go row by row into these two equations and pick what you have. What do you mean? Well, if x1 is 0 and x2 is 0, what happens? 0, 0. S1 is 32. 0, 0. S2 is 84. So this completes the first row where the first two were 0. And then we had x1 is 0, s1 is 0. And now I need to figure out what x2 and s2 are. So x1 is 0, s1 is 0. So 2x2 is 32, and you get x2 is 16. Alright, go to the next one. Let's see, x1, 0. x2, 16 I know now. s2, don't know. So we have to figure out what is s2, and s2 is 20. I then do this same procedure for every possibility. Remember, there were 6 of them. So picking which two are 0, plugging it in, and solving for the remaining items. The last row is probably the most complicated, where S1 and S2 are 0, which means you're solving two equations and two unknowns. So I'm going to use elimination. I'm going to multiply this first row by -3 and then add them up. And if we do that, see, these cancel. -2 x2 minus 12. And so I get x2 is 6, and if x2 is 6, I can solve for x1. So our original table where two things were 0 in red are all the items that we just found. There are two rows where I have the s's are negative. we throw those out. Any row where your slack variables are negative, they're not valid. So they're gone. What these other rows are essentially the corners in our problem. And so if I want to maximize something, I simply now pick each of the corners and plug them in. 0, 0, 0, 0, 16. Not this one, not that one. 28, 0, 20, and 6. I plug them into the thing I want to maximize. And so what we found is that the maximum would be 1480, and it occurs when x1 is 20 and x2 is 6. That's the basic idea. And so, in question 1, they're giving me x1 and s1 are 0. And they're saying figure out the other remaining items. Alright, so if x1 is 0, s1 is 0, you simply get 7x2 is 42, and you get x2 is 6. If x2 is 6, alright, x2 is 6, this is 0, I now can figure out what's s2. Question 2 is similar. They're going to give you two different items, is 0, and you're going to figure out x1 and s1. Notice this would not be a viable solution when we're trying to maximize because one of your s's is negative. In question 3, they want us to write down the constraints with slack variables. Well, that's just adding in S1 and adding in S2. Similarly, in question 4, alright, here's question 4. Put in my slack variable. There's only one constraint. Easy enough. Question 5. Alright, the basic variables in solution D. Okay, so come to my table here. Here's D. The question is, which ones are the basic variables? And the basic variables are the variables that are not 0. So, x1, s2. Question 6. We have a partially completed table. Alright, notice how they picked 2 at a time to be 0 all the way down this table. Our focus is on solution G. Okay, here's G. x2 is 0, s3 is 0. So what we're trying to figure out is x1. I'm trying to figure out s1 and s2. So come back over here. Here are all the variables. I'm going to plug in x2 is 0, s3 is 0, and figure out what's going on. So let's see. If this is the case, all right, that's gone. x1, s1 is 23. Let's see, x2 is 0, so I get 2x1, s2 is 32. Okay, and let's see the last one, x2, 0, s3, 0. Oh, that's good. 3x1 is 45, so x1 is 15. That's good news because if I know that it's 15, I can plug it in here and figure out the remaining 2, which we did there. Alright, in question 7, same situation. We're looking at I. 2 of the variables are 0, s1 and s3. So you simply step through and plug in these two facts and then figure out the remaining variables. In this case, we had to solve a system of two equations and two unknowns by multiplying the top one by -1 and adding. All right, in question 8, again, they just want us to put in the slack variable. Okay. And then we want to figure out all the basic ideas. All right, so if this is 0, 0, what's S1? Right, so 0, 0, S1 is 10. And so now you step through this equation where two things are 0, and you figure out these three things in the boxes. Now the final question is, which of these are feasible? Well, that's easy. We look at S1, our single slack variable. Are all the S1s positive? Yes. Therefore, all of these are feasible solutions. All right, question 9. They want us to put my constraints in terms of slack variables. Okay. And then fill out this table where two variables at a time. What variables? We'll see here. Here's x1, x2. We had two slack variables. So again, I pick two variables at a time to be 0. And then I can step through this whole process to figure out the remaining items. Okay, so which ones are feasible and which ones are not? Feasible, both S's are positive. No, one of the S's is negative. Feasible, yes. Yes, no, because one of the S's is negative. Okay, so you can step through and figure out what's feasible or not. This is not overly complicated, it's just long and tedious, and you have to be extremely careful when you're calculating the remaining items.